Hello, welcome back to my Allen Bradley PLC test bench. Today I'm going to do an update on the 1771 QB module. This is the PLC 5 linear positioning module. And these were in service for many years, and there's still hundreds if not thousands of them out there still in service. In British Columbia, where I am, there's all kinds of little sawmills here, there, and all over. And there's all kinds of even larger sawmills and different industries that use these, and they just don't fail. When they do fail, they just die and you replace them and away you go. So anyhow, we've got our QB module which goes in our chassis, and we have two Tempesonic rods. And as your this magnet in the middle is where your position is read from. And there's two series here. This is the G series, which is slightly older, and this is the older series from that. This is second generation. So, but they still work perfectly. So what we'll do is I've got three modules here. I've got a working module, everything works perfectly in the chassis. And I've got two modules with problems, and I'll show you what happens with them. So first we'll just get a little closer here and go through the hardware, and then I'll go over to, switch over to Snagit so you can see the screen, and we'll do it that way. Okay, real quick part on the hardware. So you need a power supply. You actually need a couple of power supplies. You need your plus and minus 15 volt DC, that's 15 volt. You need plus 5 volts, and then 24 volts you can use for your, there's a set of discrete inputs you can use on your card. Discrete inputs and discrete outputs. And then you settle around here. You need your Tempesonic rods, and like I say, this magnet, which encircles the rod here, would be fixed inside of a hydraulic cylinder or an air cylinder or anything you're sensing position from, and as it moves it changes the wavelength inside the rod. So there's the basic hardware, and then of course you need your modules. Now this is all wired into, get back up here a little bit. So there's our working module, and let's get a little bit closer. And it's all wired up. We have terminal block as you'd have in your term strip with our power supply here, our two different channels, and feedback and output, and these are outputting to, it's in voltage mode, to my two voltage meters. And we see here, there, you can see in the top meter, number 2, probably easier to see in number 1. As I move the magnet, it shows that it's out of position and is putting out voltage to pull it back into position, whether it be your valve, your motor, or whatever it is. So now we'll go into the program with Snagit. The two modules I've got that have problems, come back down here a little bit, are these two here. This one, the input section is good on it. It reads the rods, but it doesn't put out any voltage. And your voltage and current are all set at the back. You've got your 4 set to dip switches, and you set those according to the sheet. This one, everything on it's dead, and you plug it in, nothing happens, doesn't matter what you do, but we'll go over that. So anyhow, that's about all we can show here. I'll stop the video now. The next portion you'll see is Snagit, and then we'll come back doing on the screen, and then we'll come back, and what we'll do is the one with the good input section but the bad output section, we'll pull the module apart and just have a look, see if we can see any burnt things or just as a curiosity. So back shortly. Okay, so let's just go over how to change out a module in a chassis. So being this is 1990s technology, some of it as good, as solid as it was, you needed to take a little bit of precaution. So the best practice is you power down the chassis and the processor so everything's stopped. You turn off the power to the 5 volt and the plus minus 15 volt. That way, for one thing, you're not producing any arcs, you're not spiking the module. Undo the wiring arm, pull it out, and place it down on your surface. Now, this module here is the one I talked about earlier, where the input section is dead and there's no LEDs, nothing. And we know that everything was working here on the chassis with our good module. So we put this in, seat it in nice and tight, plug on the arm, turn on your 5 volt and your plus minus 15 volt. Now you can do those either way, it doesn't matter. Just give it half a sec, power up your chassis, and chassis goes into run mode, as you can see by the active lights on our inputs and outputs. Nothing happens on the module. And when we look at the screen, drop back down here. So here we are at the screen. Really hard to see that, but we will zoom in. And as you can see, it's giving us our done bit on the block transfer. Now if we go into the setup screen and we just go over to here, again down just a little bit, you can see, and if we go into the extended status screens, and we're not getting any position back, as you can see right here, and because we're not getting any position back, it's not, doesn't know what to do with it. There's no analog output, there's nothing. If we go into axis 2, same thing. So that we know that module is completely dead. Something's happened to it. I don't know what. Customer gave it to me to test. So let's just do the same thing. Just leave it on there. I will power down the chassis, turn off my power supplies, remove this module that we know is completely dead, and then I've got this module that input section is good, but there's no outputs. So, same procedure. Plug it into the chassis, put it on, turn on our power supplies, half a second or so, power it up, and we are in run mode, and it comes up, it's got a fault, as you can see right there. Hopefully it'll, there we go. Fault is on and both lights are flashing. So let's go back online, and you can see we are in axis 2. We've got our input position. If I move the magnet, you can see that we get a change in position that's red. Our analog out, because it is sensing a problem on the output, is at 0. So we go into channel 1, same thing, You can see where it says 9.67. I move the magnet back and forth. 7. Go the other way, goes up to 13, 14. Now this is not calibrated. There's still more programming that it would be done in a system, and our analog out is dead. So that's what happens. We've got our red fault light on, and loop 1 and loop 2 is flashing green. So that's where we know that, and we can see that it's reading the position. So now what we want to do is set up, we'll pull the module apart, have a look at see if we can identify where the output section is, and have a look at it. So again, same thing, power off, remove the module, put it on the desk, go back to our original good module, power on, chassis on, and goes into run mode, and we're back into our 2 solid green lights, which we know shows us good. Go back down to the screen, retry, and it's saying that we're at 11 inches. I move it a little bit, and you can see the percentage analog out, which in this case is how many volts it's putting out. Back and forth. And we go to the other channel, which is number 2. Same thing. It says it's at 24 inches, and you can see plus minus percentage out. So there we go. So our next step is going to be get swung around here and set up, and we'll pull this module with the dead outputs apart and have a look at it. Back in a minute. Alright, so I've moved the camera onto the bench here, and let's pull this module apart. It's actually very easy. There's only 4 screws. And again, this was made in the 90s, so you know it's going to be made to work on. So, pull our cover off. A few little star washers on there. Here's the first card. Now there's 2 cards in this module. And you pull it apart. There's a header here that plugs into a header here. And here's our switches for picking voltage and current. So let's have a look here and just physically looking without knowing exactly where everything is. There's no obvious burnt components in there. So without having the diagram and the experience on fixing these, I'm going to suggest that it's probably these 2 components here, because the top half and bottom half are one axis and the other. We look at this side of the board. There's nothing on there. This is all this is the technology it takes in the older cards to read position on those Tempasonic modules. It takes all of this, as you can see. So there we go. Without obvious burnt connections, burnt components, there's nothing there that shows up anywhere. And these things, you send them out to shops. I sent some out to a shop a couple of years ago, and I wasn't too impressed. It came back in worse shape than when I sent it out. And got a hold of the guy and talked to him, and he said, well, we just replaced components that we know had failed on the last one we fixed. So finding a good shop nowadays to do these is going to be a little difficult. So there we go. I know it's a little long-winded, but that's about all we can do with these ones. Subscribe if you'd like. Come back often, and appreciate your time stopping by. Have a great one.